Welcome to Maths for You YouTube channel. A past question on differentiation is an Oxford and Cambridge past question. In a science experiment, a substance is decaying exponentially. Its mass m grams at time t minutes is given by m equal 300 e to the power of minus 0.05 t. Find the time taken for the mass to decrease to half of its original value. So let's deal with this part of question. So the model equation is m equal 300 e to the power of minus 0.05 t. The before finding this half of its original value, we need to find the original value or the mass of its original value of that substance. So to do that, original value, which is when t equals 0. So m equal, m0, call it, equal 300 times e to the power of 0.05 times 0. That is 300 times e to the power 0, e to the power 0 is 1, therefore 300. So the initial value of that substance, initial mass of the substance is 300 grams. So having got that, now we need to find the time taken to decrease that 300 to 150, because half of its value, half of its original value is 300, we found, so half of its value. So half of m0 is 150 gram. We can use that equation again. That is, this is m equal 300 e to the power of minus 0.05 t. That equation again, we can use it. M is 150 because of it's reduced to or decreased to the half of its original value is 150, equal 300 e to the power of minus 0.05 t, the time you have to take to get that half of its original value. So 150 common. So left hand side is 1, right hand side is 2, and bring that the minus power to positive, so bring it to denominator. So 1 equal 2 over e to the power of 0.05 t. Cross multiplication, e to the power of 0.05 t equal to, then if you take log both sides, take log both sides, that will be 0.05 t, because of when you take it, the log, e to the power e log base to e is 1, therefore 0.05 t, and this side is log 2. And from that, t equal 1 over 0.05 times log 2, and bit of calculation work, and t equal 20 log 2, bit of calculation work, that is it's 13.5 minutes. So it takes 13.5 minutes to make that substance from its original value to half of its value. So from 300 to 150, the time taken is 13.9 seconds. That is the first part of the question as done. The second one, a second substance, another substance, is also decaying exponential. So that means they are indirectly telling us we can use the same type of that initial equation. Initially, its mass was 400 gram, and after 10 minutes, its mass was 320 grams. So it's decreased to 320 after 10 minutes from 400. Find the time at which both substances are decaying at the same rate. So the rate, same rate. The rate has a meaningful word, that is, for this question. So what they're trying to say is the rate of change of decaying. Rate of change of decaying. When you say rate of change, it's directly, that's a differentiation they are telling. So the differentiation, we'll come to that. So let's, so the second substance, and again the decaying, so I just compare it, but we don't know any values, the coefficient of E value, and the power, sorry, the value in front of T, we don't know. So I just took it, the model equation G for the second substance equal P times e to the power of qt. So P and Q, which we need to find, they both are positive. Um, so at t equals 0, the G0 is 400 because of initial, the mass of the substance is 400 is given. So from that, we can find 400 on the left-hand side, right-hand side, P times e to the power of T is 0, e to the power of 0, that is 1, P is 400. So P found. Now we need to find Q, then we have a complete the formula or the equation for the modeling equation. So after 10 seconds, after 10 minutes, that the mass is reduced to 320. So the left-hand side G10, the 320, the right-hand side 400, and e to the power of minus q times 10t. So from both sides, the left and the right, 80 common. So 320 divided by 80 is 4. 400 divided by 80 is 5. Again, I just bring that minus q or 10q to denominator. So 5 over 10q. Cross multiplication, e to the power of 10q equal 5 over 4. So 10q, again, both side log, take both side ln. So if we do that, it's just 10g because of ln e to the power of 10g is 10g. And this side, the right-hand side, ln 5 over 4. From that, g equal 1 over 10 ln 5 over 4. Again, use the calculator work. So just after using this ln 5 over 4 and divided by 10, it gives you the value of q is 0.0223. Right, now we have a full equation. The m is already been given. M equals 300 e to the power of minus 0.05t. And the g is which we took it and then found the values. So g is 400 times e to the power of minus 0.0223t. So we have two equations. What they say in the question, that the rate of change at a particular time, the rate of change or decay, not all the time, at a particular time, the rate of change of decaying is same. So that what they say is the differentiation of the mass with respect to t at a particular time is equal. So the differentiation of dm of dt equal the differentiation of the dg over dt. So the differentiation m with respect to t equal the differentiation of g with respect to t are equal at a particular time, at a particular time. That time we have to find. So dm, start with m, we know that. No, dm, the differentiation of m with respect to t. So dm of dt, 300 e to the power of minus 0.05t. So that is a differentiation of that, same as that, e to the power of 0.05t. And then minus 0.05t, differentiation of that is minus 0.05. Having completed the 0.05, it's minus in front, so I took the minus here, and then 300 times 0.05 is 15. So I just two decimal, both zeros out, 3 times 5 is 15, e to the power of 0.05t. So now we have found the rate of change of m, the first substance. We found it. So, right. Then we have the G equation, the modeling equation. The G equal 400 e to the power minus 0.0223 t. Then differentiate with respect to t. So dg over dt equal 400 e to the power of minus 0.0222 t. The differential is that. Then differentiation of minus 0.0223 t is become minus 0.0223. Then take the minus to the front. 400 times this one, it will be, using the calculator, is 8.92 e to the power of 0.0223 t. So that is the rate of change of G is minus 8.92 e to the power of 0.0223 t. What we have been given, the rate of change of the first substance and the rate of change of the second substance, the decaying rate of change of first substance equal second substance. So we can equate this differentiation of the first equation and the second equation. So minus 15 e to the power of minus 0.05 t, and the right hand side minus 8.92 e to the power of 0.0223 t. From that, just separate that e to the value and the numbers. So left hand side, and minus minus cancel, of course. That's 15 over 8.92 equal e to the power of minus 0.0223 t divided by e to the power of 0.05 t. If you could make that the denominator to numerator, that will become positive. So that means e to the power of 0.05 minus 0.0223 t. And the right hand side is 15 over 8.92. This one, the left hand side, e to the power of, if you could take away from 0.05 and take away that 0.0223, that's give us e to the power of 0.0277 t, that is equal 1.6, because of 15 over 8.92 is 1.6. Use a bit of calculator, and the value is 18.73. So the time is 18.73. After 18.73 minutes, both rate of change are equal. Thank you. Please subscribe the channel and pass this or share this contents with other students and friends. Thank you.